Section 9.3, solving quadratic equations using square roots. So what we're going to look at here, instead of graphing, is looking at equations that have just an x squared and not an x term. And so there are three different scenarios. When we're solving the equation x squared equals d, and d is a positive number, then x squared equals d has two real solutions. This is like the two x-intercepts that we'd see from the graphing. Positive and negative square root of d. So that's like our first example, x squared equals 12, where 12 is positive. What we do is we take the square root of each side, and we're going to get x equals, now we put a plus or a minus, we have to include that. That means we're going to have a positive answer or a negative answer. We have the square root of 12. Now, we could get the approximate answer, but we want to keep it exact. We know our answer is going to be somewhere between 3 and 4, because 3 squared is 9, 4 squared is 16. But we're looking at getting the exact answer. So I think about 12 as being 4 times 3, because 4 is a perfect square. And that's just going to give me plus or minus 2 square root 3. That's a square root in there. And that is my answer, or my two answers rather, for my first problem. I have a positive 2 times the square root of 3 and negative 2 times the square root of 3. And that's my solution there, or my two solutions. The second example is when I'm saying x squared equals 0, then it's just going to have one answer, which is just going to be 0 itself. So with this example, x squared equals 0, I go to take the square root of each side, and that's going to leave me with x equals plus or minus 0, but plus or minus 0 doesn't really make a difference. I'm just here going to have x equals 0 as my one solution. This is like when my graph just hit the x-axis at one point at its vertex. All right, and then my third example is when my value x squared equals a negative number, I'm going to have no real solution. So if I look at this last example here, x squared equals negative 25, when I go to take the square root of each side, I would get x equals plus or minus the square root of negative 25. But unfortunately, there's no number that works for that. There's no way to multiply two numbers together and get a negative, two numbers that are the same, and get a negative. So for that, we say no real solution. In the future, we're going to learn about something called imaginary numbers, and that's what we would use there. But for this, we're just going to say no real solution. And that's when our graph would have no x-intercepts. It was no solution there. We have no solution here as well. All right, let's get some practice in. All right, so let's see how we would solve a quadratic equation, including x squared. The first thing that we're going to do is we're going to isolate the x squared as in a typical equation. So what that looks like is trying to get the x squared by itself. In this first example, x squared plus 6 equals 42. I'm going to subtract 6 from each side. That brings me to x squared equals 36. Now the x squared is isolated. Now I want to determine the number of solutions. This is going to just tell me if I need to go on or not. In this case, I have x squared equals a positive number, which I saw on the previous page means I have two solutions. So I'm going to go forward with the process. I'm going to find the square root of each side. And so I did the square root and the square root, and the square root of x squared is x. The square root of 36 is 6, and I have to make sure that I include plus or minus. When we put in a square root, we need to include plus or minus. This is something that's going to come up later, and we have to do it now as well. All right, so let's see if we can follow this process for the next couple of examples. For this next one, I'm trying to get the x squared by itself, so I'll start by adding 4 to each side, which is going to bring me to 5x squared equals negative 5. And then divide by 5, and I get x squared equals negative 1. Now at this point, I can realize that x squared equals a negative number here, which tells me that I must have no real solutions. I don't need to go any further with that. Don't worry about the imaginary numbers right now. And then finally, with the last one, 4 minus x squared equals 4. Try to get that x squared by itself. Start by subtracting 4. That leaves you with negative x squared equals 0. Divide by negative 1. X squared equals 0. And now I know that because I have x squared equals 0, that I'm only going to have one solution, and it's always going to be the same. It's always just going to be x equals 0. Take the square root of each side, and you'd see that that would be the case pretty quickly. You can even write it in if you want. The only difference with that one and the first one is that there's no need for plus or minus because there is no such thing as negative 0. All right, hope this is pretty clear. Okay, so sometimes this gets a little bit more complicated. Maybe we don't just have an x squared, but we have something in x in parentheses, and that's being squared. So basically what we do is we treat that x plus 3, in this case, which is in parentheses, as like an x from before, and we want to get that by itself. So I'm going to start by subtracting 5 from each side, and that's going to give me x plus 3 squared equals 25. Now, my goal was to get this set of parentheses by itself, just like before it was to get an x by itself. I can't touch the 3 that's inside until I get rid of the squared up on top. So I'm going to take the square root of each side. Because 25 is a positive number, that's why I'm continuing with this, and I'm going to get two different solutions. The square root of x plus 3 squared is just x plus 3. The square root and the square root basically cancel out there. Now I want to include plus or minus because I'm putting in a square root symbol there, so I have to have the plus or minus. There's two answers, and the square root of 25 is just 5. Now what this actually means is I'm actually going to have to get two different equations here. I'm going to start by subtracting 3 from each side, and my answer would look like negative 3 plus or minus 5. I'm just going to scroll up a little bit here. If that's the case, I actually can create two new problems to get my answer. That means I could take negative 3 and add 5, or I can take negative 3 and subtract 5. Should be a negative 3 there. Which means I'm going to get two answers. Negative 3 plus 5 is 2, and negative 3 minus 5 is negative 8. So those are my two solutions for this one, 2 and negative 8. I can go back into the original and plug in, and you'll see that that will work out. Same type of thing for the second problem. We want to get that x minus 6 squared by itself, so I'm going to divide each side by 2. That's a 2. And that leaves me with x minus 6 squared equals 3/2. Okay, so now I'm going to take the square root of each side, and unfortunately something less convenient happens. The left side is x minus 6, that's fine. I know I have to include my plus or minus, but I have the square root of 3/2, which does not work out nicely. So what I need to do there is I need to try to reduce the fraction. It doesn't work. So I'm going to write it as a fraction of two different square roots, the square root of 3 over the square root of 2. I know I'm not allowed a fraction inside of a square root, so I try this. But neither of those simplify. So this is where I'm going to have to multiply by my fancy 1. Multiply by the square root of 2 over the square root of 2, and I'm going to get x minus 6 equals plus or minus. Now my numerator becomes the square root of 6 because I'm multiplying 3 times 2. My denominator is the square root of 4 because it's 2 times 2, but the square root of 4 just ends up being 2. So now I'm at my final step. I can add 6 to each side, and when I add the 6 to each side, I'm usually going to put it in front of the plus or minus. I'm going to have 6 plus or minus the square root of 6 over 2. And because it's going to be a radical there that doesn't simplify, I leave that as my final answer. 6 plus the square root of 6 over 2 and 6 minus the square root of 6 over 2 are my two different answers. But I don't need to combine them anymore because I don't have any like terms, as opposed to on the left where I had just integers. So these are definitely more complicated, but it's really the same process. You just can't touch what's inside parentheses until you get rid of that squared. All right, hope that makes sense. So here are 6 problems, kind of a combination of a few different ones, or the 2 different types. Try to solve each one, then come back to check your work. Alright, let's see how you did. Alright, so here's what we're looking at. First one was very straightforward. Isolate the x squared, take the square roots, include the plus or minus, and you get x is positive 5 or negative 5, plus or minus 5. Second one, you have x squared equals negative 2. Since that's negative, we know automatically there are no real solutions. For number 3, we end up with x squared equals 0, which means we're only going to have one solution, x equals 0. For number 4, we have x plus 7 squared equals 0, which means we're going to take the square root and still have x plus 7 just equals 0, which means x equals negative 7. On the 5th one, we have to isolate the x minus 3 squared by dividing by 4. Taking the square root of 9/4, we get 3/2. And that is a fraction, but when we do 3 plus or minus 3/2, we just do that one at a time. And 3 plus 3/2 is 9/2, or 4.5. 3 minus 3/2 is 3/2, or 1.5. So those are my 2 different answers. I do want to combine them and end up with that as a final answer. I don't want to just have 3 plus or minus 3/2, since I can get numbers for each. And then for the 6th one, I end up getting 2x plus 1 equals plus or minus 6. So when I subtract 1 from each side, negative 1 plus 6 is 5, excuse me, and negative 1 minus 6 is negative 7. So I have them kind of in a backwards order here. I do the minus 1 first and then the plus 1. And but I just end up with x is negative 7 over 2, or x is positive 5 over 2. And again, you could plug in and make either of those work, but that's all that you would need to do. Alright, good luck with the rest of this.